Hey, Lars here. Here I am in the lab working on an old ATD controller. It's a 375, which is a really old one, and I got it in and I want to modify the pump. I actually put a new pump in it, a high flow pump, and I did a few other things to kind of modify it, tweak it a little bit. We have something called a Fascia Stretch that are in the new units, and I tried to add that one in here. So it was actually a lot of programming. It was quite a fascinating challenge, but I figured it out. So what I want to do is actually kind of show you some of the modifications that I put into this thing and actually how I control them. Let's check it out. So what I did was actually, I will put these on so I can actually see what I'm talking about. So what I did was, here's the old control circuit. So that's in there. That's actually an Arduino that controls it. So if you're interested in Arduinos, then take a look at what's going on here. So that's the Arduino that's controlling it. Now the old pump was much smaller than this, and it used to just connect directly to this circuit. Actually, check that out. That's a little tiny Omron relay. It's just the smallest little relay that I've ever been able to find, but they're really cool. I use them for lots of little interesting projects. Anyway, so this was controlling the pump, and it was controlling the old solenoid. So that's the old solenoid. It's a little bit smaller than the new solenoid, and this is the new solenoid. As you can see, it's a little bit bigger. So this newer solenoid is going to deal with more actuators, because this particular control unit is going to be controlling, I think, 4 actuators, and they're going to be much smaller, much larger, pardon me, and they'll have a higher flow rate. So here we go. That's why actually, well, let's talk about that. So because they have a higher flow rate, I needed the bigger pump, and actually has a much higher pressure as well. But the other is that when they evacuate, the way that they evacuate is that this standard solenoid that I use in most of my units, it just becomes passing, right? So when I de-energize it, it becomes passing. It's a normally passing valve, solenoid valve. So anyway, so this new one is also the same. So what happens is when we turn it off or de-energize it, right? Because it's got a coil in it. So when we de-energize it, it just vents air. Because we're dealing with 4 cylinders, it's a lot of air that's got to be vented. This valve has a larger orifice than this valve in that it can actually handle a higher flow rate, which is actually required to vent 4 cylinders. Okay, so continuing on with the control here, what I did was to actually control this guy, I needed to do 2 things. One is I needed to control this separately from this. This old unit actually everything was driven right on that relay. So this relay was actually controlling the solenoid and the motor at the same time. Now I need to actually drive them independently because I added the fascia stretch. And the fascia stretch is something that actually, after, if you turn it to 60, actually up to 60, it's past 57. If you turn it past 57, it goes to fascia stretch, which is actually a 5-minute stretch. So it will just come on and stretch for 5 minutes, period. So what that's going to do is it's going to have the pump on. If I have it in the old configuration, and just like reprogrammed it, it wouldn't work, because that would mean the pump would stay on for the whole 5 minutes, which is not good for the pump. It would warm up and it would eventually degrade, because the diaphragms that are in here, there are 4 little rubber diaphragms in here. They would degrade, they'd get hot and they'd eventually go, and I'd have to replace this motor actually probably in a year or something. So what's going on is that I've separated them, and going back to this circuit, I built this little extra control circuit. That's a MOSFET, super cool thing. I should do like a whole other video on MOSFETs. It's really cool, way better than relays. But relays also have some really neat things that you can add into them as well. So sometimes when we're relays, sometimes you want MOSFETs. In this case, I used a MOSFET to control the motor. So, and I actually tied into just a different pin on the Arduino by actually soldering wires to the back. So, this MOSFET controls the motor. And don't forget your, because if you're controlling any kind of load that is a coil, don't forget your flyback diode. Don't forget that. So anyway, here we go. So I've got a MOSFET in here, and the MOSFET is controlling this, but not only is it controlling the motor separately from the solenoid, it's controlling the motor with speed. So I've got this little trimming pot that is actually connected to the circuit, again, through like, soldering on one of the pins in the back. So I've got this guy that actually goes onto this circuit and controls, actually no, this talks to the Arduino, and then the Arduino actually talks to the MOSFET and controls the speed of the motor. So I can control the motor independently from the solenoid. Now I can also control the speed of the motor, which I will demonstrate momentarily. So when I actually put this thing together, this is just going to be just kind of hanging out here. So I get a message to John, because John, you're actually going to be dispensing this in clinic. So when you're actually putting it on and testing it, what you're going to do is you'll have to open it up just to access this pot, and it works. It's pretty simple. All the way counterclockwise is the slowest speed of the motor, and all the way clockwise is the fastest speed of the motor. Also, I guess I wanted to make a programming note and maybe a wiring note. If you use a pot as a sensor that is going to give you information that's going to go into some circuit or a controller of some type, you have to think of the polarity. So, you're going to have your two legs of your pot, two outside legs of your pot. One's going to be power, one's going to be just to ground. And then the output is going to give you a variable voltage out as a voltage divider. So, I mean, if you know pots, you know that that's how they work. But it's interesting to note that if you hook it up one way, as you turn it clockwise, you get less voltage. And if you turn it counterclockwise, you get more voltage. So what I did was I wired it that way. And then when I tested it, I was like, oh, that's not right. Because I turned it all the way clockwise, and the pump was like really slow. I don't know. It's kind of like that. So what I did was I just went into the programming, in the Arduino programming, and I just flipped in the mapping function the two last numbers. You just flip them. So if you do wire a pot backwards, you can just go into the mapping function and just flip them. So with all that said and done, let's plug this in and press play. So I got the pump here. This is a 12 volt transformer. Actually, it's a voltage power adapter, but it's a transformer power adapter. It's not a switching one. But anyway, it's got 12 volts. That's for the old units. I used to run them on 12 volts. I ran the new ones on 9. But anyway, so I wanted to keep this at 12 volts because one was this circuit is actually designed to regulate 12 volts. But the other is this motor can handle 12 volts. So if I do push it to 12, then it'll actually put it more flow than if I ran it on 9. So I've got the motor running right off the adapter as opposed to running off the power from the circuit. Okay, here we go. I will put that there. No, I will, yes, wait a second. I will turn this all the way down, counterclockwise, and I will put that there, and I will press play. So I'm going to turn this guy on, and get that out of the way, and we'll watch this. It's going to go slowly. So I'll just turn it to 20 seconds. Give it a sec. Give it a sec. So it's going slowly. So I'm going to turn it off, which actually de-energizes the solenoid, which makes it vent because it's normally passing. Here we go. So when I push this in, you can listen to the air. Let me turn this off. Listen to the air. So that's a higher flow rate than I could have got out of this thing. And if I'm venting four of these things, then yeah, you need a bigger one. So here we go. So I'm going to crank that up. So first of all, let's do this kind of quickly. So I'm going to turn it on and we'll watch the speed at the lowest speed. Hear the motor? That's the lowest speed. Okay, so John, this is what you're going to do. You just simply go in here and I'll just glue this to the top of the motor. Not glue it. I'll stick it with my cool sticky tape. This is the coolest sticky tape. It's made by 3M, and it's way beyond sticky tape. It's really nice and thick. Anyway, there we go. So, I'm going to crank that up, and we'll press play again and watch that. Ready? It'll go more quickly. So, you can hear the motor, it's running more quickly. So, I wanted to put that in so you can adjust the speed because it was actually really important for me to do that because it could have been that the speed of this was actually too much and that the cylinders on the braces would actually just extend too much, and it would be too quick of a stretch. So here we go. So yeah, just find your sweet spot by adjusting that, and you know how to do that. Adjust it during the on cycle. Now that's something that makes me think about the cycle. So how I changed the programming a little bit. So the on cycle, if I set it to, wait, here we go. Yeah, I was looking for this. So if I set it to 20, it'll just come on. The pump will come on for 20 seconds, and after 20 seconds, both the solenoid and the pump will de-energize, or the pump will turn off, and the solenoid will de-energize, and then that'll be it. Now you can hear the pump stressing a little bit. Right, so it has maxed this out. So I'm assuming it will maybe max 4 cylinders out. in 30 seconds. Now here we go. Here's the venting, right? That adjustment, I'm going to change that timing adjustment. But anyway, here we go. That quick venting timing adjustment, I'm going to change that. That's just for testing. So if you set it past 30, what happens is it comes on, the pump will come on for 30 seconds, and this is where I needed the independent solenoid in the motor. That's why I built that circuit. What will happen is the actual pump will come on for 30 seconds, the solenoid will stay energized, and the pump will de-energize. And then after that, every single 20 seconds after that, forever and ever, if you, well, turn it to fascia stretch, it will actually, as we know, stay on for 5 minutes. During that 5-minute cycle, the pump will come on for 3 seconds every 20 seconds. Because, here, it shut off, but you can see that, oh my, oh, that hurt. That's 15 psi. So, it's holding. Now, it'll hold for, there we go. There's that venting cycle. It's come on quickly because I've got it in diagnostic mode. Anyway, so that's what that's all about. So when you actually turn it to 60 and it goes to 5 minutes, during that 5-minute cycle, every 20 seconds, the pump will come on for 3 seconds, just to deal with any pressure loss, any kind of leak anywhere, and also just to give that extra little bit during that stretch. So every 20 seconds, it'll just it'll pressurize again, just in case that stretch just let go a little bit. It'll give you that extra little stretch every 20 seconds. So that's what's going on here. I think I've explained this completely. Yeah, about the pot, putting the pot in here and the circuit, and yeah, I think we're good. So that's kind of how you're going to hook this up and use it. I think we're good. Over and out.